Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us solve the problem on matrix of linear transformation, where the given matrix is given by, they have given with respect to matrix A, which is defined with respect to linear operator R2. Find the matrix of linear transformation relative to the basis U1 and U2. To find this condition, let us simplify the matrix. That is, first let us consider the given A, which is equal to 2 4 5 6, and the basis S, which is equal to u1 comma u2, which is equal to 1 minus 2 comma 3 minus 7. We need to find the matrix of linear transformation with respect to coefficients, that is C1, C2, or A11, A12, A21, A22. How to represent that coefficients? There is a standard condition. We use the previous method, that is linear combination method. The linear combination, which is A u1, which is equal to c1 u1 plus c2 u2. This is the first term, and the next part is A into u2, which is equal to c1 dash u1 plus c2 dash u2. What is c1 c2 c1 dash c2 dash? That is what we call it as the coefficient of the matrix. To find this one, let us represent first. Let us find AU1 and AU2. What is AU1? A represent the matrix 2, 4, 5, 6 into U1 represent the matrix 1 minus 2, which is equal to the order 2 into 1, 2 plus, okay, plus into minus 4 2s are 8. Now 5 into 1, 5, 6 into minus 2, minus 12. That is minus 6, minus 7. This is the value of AU1. Similarly, let us represent for AU2. What is AU2? AU2 represent 2, 4, 5, 6 into what is U2? We have 3 minus 7, which is equal to, let us multiply, 3 2s are 6, 4 into minus 7, minus 28. Now 5 3s are 15, minus 6 into minus 7, 42, which is equal to 6 minus 28, we get minus 22. 15 minus 42, we get 15, 30, 25, and minus 27, which is equal to 27. This is the AU2. Now let us represent. Now we can simplify, where the order of A was 2 cross 2, when the order of the basis was given with respect to 2 cross 1 and 2 cross 1. So we have reduced order 2 cross 2 into with respect to 2 cross 1 and 2 cross 1. Considering these two vectors, we define with respect to C1 C2 and C1 dash C2 dash. First, let us represent A U1, which is equal to C1 U1 plus C2 U2. What is AU1? We have minus 6, minus 7 into C1. What is U1? 1 minus 2. What is U2? We have 3 minus 7. Just multiply the coefficients. 6 minus 7, which is equal to C1 minus 2 C1 plus 3 C2 minus 7 C2. Okay, first let us add the operation with respect to first term and represent it in the linear equation form. That is, first term addition operation, first element, that is C1 plus 3 C2 equal to minus 6. Now the second row, that is minus 2 C1 minus 7 C2, which is equal to minus 7. Consider this as equation 1, consider this as equation 2. Okay, solve equation 1 and 2. Solving equation 1 and 2, that is C1 plus 3 C2 equal to minus 6. Minus 2 C1 minus 7 C2 equal to minus 7. Multiply 2 to get the simplified value, that is 2C1, 2 into C1, 2C1 plus 3 2s are 6 C2 minus 12, that is minus 2C1 minus 7 C2, which is equal to minus 7. 2C1 minus 2C1 get cancelled. 6 C2 minus 7 C2 you get minus C2, minus 12 minus 7 you get minus 19. Minus minus get cancelled. C2 value equal to 19. This is the first coefficient value. Considering this, let us find C1. Consider equation 1 and substitute C2 equal to 19, that is C1 plus 3C2 equal to minus 6. What is, we need to find C1, 3, what is C2, which is 19, which is equal to minus 6. C1 which is equal to minus 6, 19 3 is a minus 57. C1 which is equal to minus 6 minus 57, you get minus 63. This is the coefficient value of C1 and C2. Similarly, now let us find AU2, which is equal to C1 dash U1 plus C2 dash U2. Or else we can represent C1, C2 as A11, A12 and C1 dash as A21, A22. What is AU2? AU2 we have minus 22 minus 27, which is equal to, what is C1 dash? That is what we need to find the coefficient. What is U1? 1 minus 2 plus C2 dash U2 3 minus 7, that is minus 22 minus 27, which is equal to C1 dash minus 2 C1 dash plus 3 C2 dash minus 7 C2 dash. Represent this in the linear equation form, that is C1 dash plus 3 C2 dash, which is equal to minus 22 minus 2 C1 dash minus 7 C2 dash, which is equal to minus 27. Okay, consider this as equation 1 and consider this as equation 2. Solve equation 1 and 2, that is C1 dash plus 3 C2 dash, which is equal to minus 22 minus 2 C1 dash minus 7 C2 dash, which is equal to minus 27. Multiply 2 for the equation 1, you get 2 C1 dash plus 6 C2 dash, which is equal to minus 44 minus 2 C1 dash minus 7 C2 dash, which is equal to minus 27. 2 C1 dash, 2 minus 2 C1 dash get cancelled, get minus C2 dash, which is equal to 44 plus 44 minus 44 minus 27, you get 60 71, I think so. Okay, 4 plus 3 11, 11 plus 5 minus 71, minus minus get cancelled, C2 dash equal to 71. Now consider equation 1, consider equation number 1 and substitute C2 dash equal to 71. What is equation 1? C1 dash plus 3 C2 dash, which is equal to minus 22. C1 dash, what we need to find, 3 into 71, which is equal to minus 22. C1 dash, which is equal to minus 22 minus 3, there is a 2 1 3. C1 dash, which is equal to, you get minus 2 3 5. This is the value, that is 22, that is 35. Yes, this is your C1 dash. This is your coefficient value of C1 C2 and the coefficient of C1 dash and C2 dash. Now let us represent this in the coefficient matrix. the coefficient of the matrix is C1, C2, C1 dash, C2 dash, which is equal to, what is C1? We have minus 63. What is C2? We have 19. Next, what is C1 dash? We have minus 235, and C2 dash we have 71. Now we need to represent the matrix of linear transformation. The matrix of linear transformation is given by m of t, which is equal to m transpose. What do you mean by m transpose? Row changes to column, column changes to row. That is minus 63 minus 235, 19 and 71. This is the required solution for the given set of matrix. This is how we need to find the matrix of linear transformation for the given matrix and with respect to the standard basis of. Yes, I hope you have understood these problems. For more videos, please do like, share and subscribe. See you in the next video. Thank you.